Hello, this lesson is about differentiating functions of the form y equals a e to the bx. Now, what we mean by this is e is not a variable, remember, and if you aren't aware of this, you need to go back and understand what e is, which is one of my other videos. So e here is 2.71 continuous, so continuing on, and a and b are constants. What is a constant? A and b are values like 3, 4, 7, -2, and so on. So these are not variables. And x here, this is our variable, and it will only have real values. So moving on, we need to start by reviewing y equals e to the x. And you should have already understood about the link of y equals e to the x with its gradient. And if that's not firm in your mind, you do need to go back, and there's a video on available which talks about what is y equals e to the x, and that's really important you understand that, because from that comes that when you differentiate e to the x, the answer is also e to the x, and that's one of the key pieces of information you know or need to know before you can do this next section of work. So if y equals e to the x, then the differential of y also equals e to the x. Now, the next piece of information I'm going to give you is fully explained by the chain rule, which is something that is in year 2 of the A-level syllabus. So at the moment, the reason why this actually works, you haven't quite learnt yet. So it's slightly out of order. So I would say you perhaps need to come back to this when you learn the chain rule in year 2. However, the other thing that's quite special here is that if I have a function and my function was e to the kx, where k is a constant. So I previously on the last page used a and b, but here our k is a constant. Then if the differential of e to the kx would be k e to the kx. So notice that if I have the function e to the kx and then I differentiate that, it's just the differential of the exponential. So this k to the x, if I differentiated k to the x, my differential would be k, and that's what I multiply by. So it becomes k e to the kx. So this part doesn't change. All that's changed is I've multiplied by the differential of the exponent. So if I moved on a stage, and I'm going to write this a different way because I want that flexibility in your knowledge, I'm going to now write this as I did at the beginning, a e to the bx, where a and b are constants this time. Then f dashed of x. Well, if I look back to here, what happens? I just multiply by the differential of the exponent. So here's my exponent. What's the differential? Well, x is my variable that I'm differentiating with respect to. B is my constant. So the differential of bx is b. And I can write this as a b e to the bx. So notice what's happened. This part has remained the same. What's changed? I've just multiplied by b. So that's where I started, and now I've multiplied by b. So now let's actually put this into some examples and using it. So here I want to differentiate y equals e to the 4x. So dy by dx, I differentiate by, I multiply, I am going to differentiate, but I multiply by the differential of the exponent. So if I differentiate 4x, I would get 4, and that's what I'm going to multiply e to the 4x by, because e to the x differentiated is e to the x. So here we just multiply by the 4 and it remains as e to the 4x. So here this is 4e to the 4x is my answer. I'd suggest you copy that down and that you make sure you understand it. So this is a good point to pause and have a think. Check you get that before you move on to the next example. So moving on to the next one. Here we've got y equals e to the minus a half x. So what's the part is the exponent? This part. This is my exponent. So dy by dx is equal to, if I differentiate that, I've got minus a half e to the minus a half x. And that's my differential. So are we happy with that one? I'm hoping you are. Let's move on to our final example. And by the way, if I just go back, I would suggest that you copy that out, because it's good to have these examples written down when you start tackling more questions later. So differentiate y equals 3e to the 2x. So again, this is my exponent. Dy by dx equals, the differential of my exponent is 2, so it's 2 multiplied by 3e to the 2x. So that would be 6e to the 2x. Was that what you were expecting? Did you perhaps get there as well? Okay, there's 3 examples on how this works. Copy that last one down, make sure you've got it, and then you need to do some practice.